In this project, we're going to be building a chat with your documents application. This is a very useful and common application of AI that allows the person to use natural language to engage with documents, whether that be from PDFs, text files, Word docs, or other formats. Let's consider a use case for this capability. Meet Sam, a new employee at BusyBee Wealth Management. It's a startup that specializes in financial planning and investment management. As a new hire, Sam wants to quickly familiarize himself with the company's HR policies, but he's not sure where to start or who to ask. One of the first questions Sam has is about health insurance coverage. He wants to know what the company covers and what he'll be responsible for paying out of pocket. Fortunately, BusyBee has an AI-powered HR assistant that can quickly and accurately provide this information. Sam simply types his question into the chat interface. What is the health insurance coverage? The AI assistant quickly responds with detailed information about the company's health insurance plan, including the types of coverage available, deductibles, copays, and any limitations or exclusions. Sam is pleased with the quick response and feels more confident about his healthcare options. Next, Sam wants to know about the company's overtime compensation policy. He knows that startups can be demanding, and he wants to make sure that he's fairly compensated for extra hours he puts in. Once again, the AI assistant is able to quickly provide the detailed information that he needs. So thanks to the AI assistant, Sam is able to quickly learn about the different HR policies at BusyBee Wealth Management, allowing him to focus on his job and contribute to the company's success. So now let's show a quick demo of the chatbot in action. This is the first version we'll build to show the Q&A aspect of the chatbot. We'll take the same engine in part 2 of the tutorial and integrate it into Slack, where a new employee like Sam would typically engage with this kind of chatbot. What is the health insurance coverage? What are the overtime compensation policies? Before we get into the details of the build, let's understand the concept behind how chat with your data applications work. We'll be using two architectural diagrams to explain the concepts. The first one is about upserting, and we'll then move on to querying in the next slide. The first diagram shows the components and flows involved in building and storing the information that you want to chat with. This process is called upserting. Starting from left to right, we have the data source. For example, a website containing information we're interested in. It could be PDFs or text files or other supported data sources. Next, we load the information and then we split the information into chunks with a splitter. Now, each chunk, we go through a process called embedding. This is a technical term for converting information into a set of vectors that a large language model can use to search for similar meaning. Once the embedding is done, each chunk is stored as a set of numbers associated with the associated text into a vector store. This whole process is called upserting, which means updating or inserting data into the vector store. The second architectural diagram illustrates how users can query or ask questions about the data stored during the upserting step. For example, a user might ask, what is the vacation policy? About HR policies that have been stored during the upserting stage. First, we represent the user's questions in numerical form through a process again of embedding. This allows us to then search for the closest match in meaning in the vector store where the relevant information has been stored. After matching, the vector store retrieves the closest chunks of text. These chunks of text from the match are then used as input along with the prompt and the user question to the large language model. The large language model then generates an answer based on the context provided by the prompt and the retrieved chunks. Now that we have an understanding of the foundational concepts, the next natural question is, what vector database should I choose? Choosing the appropriate database for vector storage plays an important role in determining your system's architecture, compliance, and future costs. There are two main categories of vector databases to consider. The first is independent vector database, or databases that are tuned specifically for vectors. And the second one is vector search in existing databases. Independent vector databases such as Pinecone or Qdrint may offer benefits such as fine-tune especially for vectors, but also require some careful consideration of potentially added complexity and costs. On the other hand, vector search in existing databases may not be tuned specifically for vectors, but they can also reduce architectural complexity and eliminate extra compliance concerns. So these are the pros and cons that you'll have to consider. Ultimately, the choice between these two categories depends on the specific needs of your application. So this is a comparison table that kind of gives you the pros and cons of the various facets of the two types of databases. For this course, we'll be using Qdrint as it is a very popular option that is open source based, and it has just a great free tier that's useful to get started, and the UI is extremely easy to use.